Hi, I'm Milan Gandhi. We have developed a route profitability analysis tool. This is an executable we need to open. It will take a couple of seconds to activate. The tool is activated. In this tool we've got two applications. One is the cost profitability analysis, the other one is class sensitivity analysis. Both these applications serve dual purpose. The first purpose it serves is that you can analyze the routes already been flown, and the second purpose is you can plan a particular route which is to be flown. The difference between the two applications is the key matrix of the load factor. In this application, cost profitability analysis, average load factor will be calculated, whereas in class sensitivity analysis application, class-wise load factor will be calculated. That is business class, premium class, economy class load factors. So I'll walk through the first application, cost profitability analysis. When determining the flight profitability accurately, the proper question to ask is, if I change this route, flight or hub, what revenues will be lost and what cost will be saved? Schedule planners use flight profitability data to make schedule changes to improve the overall profitability. The right measurement depends on the question being considered. To decide if a specific flight should continue flying, to decide if all the services to a specific city should be closed, to decide if a service is viable in the long term. Airline often decides to continue flights that cover all their direct costs. The first application, the key metrics such as market share, asset utilization, average passenger per flight, RPM, passenger yield, average load factor, and profit and evaluations are available to measure the success or failure of the particular route. So let's start. We are assuming this particular in this particular case, we are assuming the route has already been flown, and the origin was say Malaysia, and the destination was Denmark, and this route was flown in the previous year from January to December. So we are going to analyze the data from the 1st of January 2019 to 31st December 2019. The format is here to enter the dates, and we submit it. So this is the first screen where prior to flying this particular route, the airline has to have the demand forecasting figures that can be done via time series method, which takes into consideration of the historical booking data, and probably the figures were something like this: 102,000, and then market share for one daily flight that needs to be estimated. That can be done using the S-curve model for market share, frequency share, and say they got it around about 70% of the market share was there for this particular route. The local passengers on this flight, which have already flown, where from the origin to destination was 59,750. Then the additional traffic behind Malaysia from Denmark was say 24,000, which has already flown, and connections beyond Denmark from the origin, that is Malaysia, was some figure was 12,000. The connections behind Malaysia from destinations beyond Denmark was say 4,500. The average prorated ticket price one way was 475 for the local passengers, 450 for the connecting, 425 for that is connecting behind, that is 425 beyond destinations, and say here we'll put 450, here we'll put 425, and here we'll put 400, and this was say $375. When we submit the button, when we click on the submit button, all the calculations will be done. That is, for the local passengers, revenues will be calculated based on these figures of number of passengers and the ticket price, and the same for the additional traffic for all these three additional traffic areas. So that would become a total revenue. Additional cargo would be included. We have just taken into consideration 10% of the passenger revenues, and then there will be a total revenue for the passenger revenue plus the cargo revenue. And here we'll get the total number of passengers who had traveled for this particular route, including local passengers and the additional passengers, the additional traffic. So when we click the submit button, the calculations are done. This way the number of passengers that traveled in that particular year 2019, and this was the revenue for the additional traffic. You can calculate from this three, and for the local passengers this was the revenue. So in all, the revenue was for the passenger revenue was this much. The additional cargo 10% of this particular passenger revenues, and the total revenues was this much. Now we'll click on the next button. Here you got to input the aircraft type, which aircraft was used for that particular route. Let's say 767-300 ER was flown, which had 210 seats. Total annual flights for that particular year was 358. Origin to destination, block hours, it should be input by the hours colon minutes. So we say 8 hours from Denmark, from Malaysia to Denmark, and 9 hours from Denmark to Malaysia. And non-stop miles would be say 1383 miles. So when this data is the input, and when I click the submit button, in the back end there will be statistical calculations done. Like for ASM will be calculated, RPM will be calculated, average passengers per flight will be calculated, annual flights, passenger yield, and all the statistical calculation will be calculated and will be done. So when I hit the submit button, we'll go directly to the next screen. In the back end, the calculations will be done. So when I submit it, we go to the next screen. The calculations, statistical calculations are already done, and here we go to input the block hours for crew. Let's say for crew we assume this as $890 per hour. For fuel, say it's 3,280, and ownership let's say is $870 per hour, and the maintenance per hour would be say $710. And then we hit the submit button, we'll get the total block hour, total per block hours, and direct operating cost will be also be calculated. Submit. Here is the figures of total block hours per block hours and direct operating cost. We hit then click the next button. Here you got to input the indirect operating cost passenger service per RPM in the format of 0.00, that is in the percentage. Say we enter 0.015, so this is 1.5 cents per RPM. And then traffic service enplanement per enplanement is say $22. Aircraft service per departure say $1,800. Promotion and sales, let's take 9% of the passenger revenue. It depends on airlines what sort of percentage they need to take. General admin per ASM will say 0.002, so that is 1/5 of a cent per ACM. When I click on the submit button, this particular figures for passenger, all the service figures will be calculated based on this particular input. At the same time, operating cost, operating profit and operating margin will be calculated. So we'll hit the submit button, and here it is, and you can see this particular calculations for passenger service figures and other figures what we have input via the input value. So these are the figures for this. Operating cost is calculated, operating profit, and this is the operating margin 6.74. Now this needs to be generated in a very formatted way, which would be very easy for the user to look into this particular report. So we just click the generate report button. Report generated successfully. Click OK. Now from the folder where we had activated this particular exe file, we go there. Already this particular Excel file for the route profitability analysis is generated. So we'll open this and see the report, how it looks. This is a detailed report which is formatted. This gives a very clear understanding of all the figures. So this is what we had. The yellow highlighted cells are the user input fields, what we input currently on the user interface. So this was input, and this were the figures we input, and this is the way it is formatted: 70% and 59,740 and $450 and so on and so forth. And if you can see the revenues, this is the local revenue. This plus this into this would be this, and this is additional traffic revenues. The total passenger, this is a passenger revenue. These are the number of passengers flown over the 1 year. Additional cargo figure is this, and the total revenues is this much. So this is the first part of it. Then we input this particular figures of block hours and annual flight and number of seats and non-stop miles. So at that time I just mentioned that the calculations will be done in the back end. These are the statistical calculations. Annual flights, annual block hours is calculated. Average passenger per flight is 140 RPM. Passenger yield, ASM. These are the key metrics like RPM, passenger yield, average passenger per flight, then average load factor is there, passenger and plane, and the seat departures. Now move on. Next is in the next screen we had input this particular figures for the block hours for aircraft operating, and that was crew, fuel, ownership and maintenance. This was the total figure, and the direct operating cost is this much. And this is calculated, if you look at the direct operating cost, it is calculated via this into number of this figure, total block hour per block hour into annual block hours. So you'll get this direct operating cost, and if you move down, and we have to input about the indirect operating cost or the percentage of the passenger service, general admin, and the promotion and sales, and the other figures of traffic and aircraft service, and that was calculated, and this is what it is, the calculation about this particular indirect cost. Then we got the operating cost, operating profit, and this is the operating margin. So the operating margin for the route flown from Malaysia to Denmark for the period of 2019 from Jan to December was 6.74, so approximately 7%. So that is on every $100 invested, $7 are in returns. So it is up to the airline whether to continue flying this particular route or change the network. So this is the first report being generated where we have used the already flown route, and we have analyzed, and it's very handy for decision making. So this is the first report being generated from the first application. Now we'll go back to the user interface screen, and we'll go back home here, and we are here. So we'll select the class sensitivity analysis application. That's the second application. As I mentioned earlier, the load factors would be on the classes, that is business class, premium class, economy class, and we will use this particular applications, as I mentioned earlier, that it serves dual purpose. Both the applications, the first application, cost profitability analysis, can serve the purpose of routes already flown, or it can also be used for the planning a particular route. So in the second application, the same way, it can be used to analyze the routes flown, or you can plan a particular route to be evaluated. So the second application will plan a particular route which is to be flown, and we will evaluate whether it's feasible for the airline to fly that particular route. So let's start the second application. We'll change the origin and destination. Say origin, we'll put Boston, and the destination, say Rome, and we want to plan it from 1st of April, say 2020 to say 31st March 2021. So 1 year, we want to plan for 1 year for this particular route and evaluate it, and we'll submit this. Okay, we'll submit it. Now same, this is done, the screen changes, like this is for the business class, premium class, and economy class. Forecasting, demand forecasting figures needs to be entered. That can be also done by a casual method which uses the advanced booking data. So let's assume that they have come up with these figures, 1100, say 2000 for this particular premium class, and say 65,400 for economy class. And market share for one daily flight has to be estimated. This can be done by a quality index, quality service index model also. So let's assume it's something like 70%. We just enter 70. Now the average local fare for the local passengers, that is from Boston to Rome, is say 1150 for the business class, 795 for the premium class. Economy class is say 605, and additional traffic for this particular, that is behind and beyond, and behind from the beyond destinations, of the route Boston and Rome would be, say, 9,800 is for the business class additional traffic. Then for premium class it's something like, say, 25,850, and for the economy class, say, it's 98,400. The average prorated fare for this particular additional traffic, say for a business class, is 880, for premium class is 590, and for economy class is 475. So these are the figures input. Now when I submit, click the submit button, total passengers for business class, premium class and economy class will be calculated. Connecting passengers revenue, that is this particular revenues, connecting passengers, additional this particular revenues will be calculated here, and the local passenger revenue will be calculated here. So here I click the submit button, and this is the figures coming. This is the total number of passengers for the different classes, and total number of passengers is this. The connecting passenger revenue is this, for each class is this, and the total is this. The local passenger revenue is this. So this is the first screen, and then let's move to the next screen. Here the flight operating information has to be input in the format, the block hours has to be in the format of hh.mm, that is hours.minutes. So block hours from origin to destination, say it was from Boston to Rome, that is 13.30 hours. Here you can from destination to origin is 12.20, and distance in kilometers, say it was 9646 in kilometers. Annual departures was, say, 720, where the annual is the annual departures. So when I hit the submit button, you get the round trip block hours and the RPKs is generated. So let's hit the submit button. This is the round trip block hours, 25.50, and the RPKs. Now let's move to the next screen. Let's take that this flight is to be flown by B777-300ER, and the cost per block hour, let's assume it's going to be something like 1,450 for the crew. Fuel and oil, say $3,350. Then for ownership, say $1,030 per hour, and maintenance, say it's $740 per hour. And passenger service, that's the indirect operating cost. We'll say in the format, the same format of 0.0 in the percentage. Let's take this to be 0.020, that is 2 cents per RPK. Traffic service is $25 per enplanement. Then service is 2,000, aircraft service is $2,200 per departure. Promotion and sales, let's take 9%. And general admin per ASK, let's take it as 0.002. So these are the figures we input, and total per block hour will be calculated. We just submit it. This is calculated, and let's move to the next screen. Here we enter the all the seat configuration. Let's say the business class is configured with 28 seats, then premium is with 63, and economy class is say 246, 246, and we cargo contribution, let's take it as 8550000. Now when I submit it, all these load factors will be calculated, and you can see the load factors will be calculated, seat departures, ASK and total seats will be calculated. Let's submit it. So this is what is the load factors for different classes. Total number of seats, ASK is calculated, seat departures are calculated, total passenger revenue is also calculated. So let's move to the next screen. You just got to submit the button, click the submit button, and all you'll get calculated. The direct operating cost will be calculated with all the indirect operating cost will also be calculated at the same time, where in the previous screen we had entered this particular percentages and the figures for this. Then the operating cost will be calculated, unit cost that is also will be calculated, operating profit and operating margin. So let's hit the submit button. Here it is, and these are the figures generated. And if you look at it, the direct operating cost, and this is all indirect operating cost in totality. Unit cost is 0.046, operating profit and operating margin. The operating margin is 1.7 drop. Okay. Now we want to have the generate a formatted report which is in details and which gives a clear understanding of this particular proposed route. Report generated successfully. Okay, let's go to the folder from where we have executed the executable, that is the exe file, and here you can see this particular report generated, route profitability analysis under scope class. This is different from the first report which was generated. So this Excel file, will open the Excel file. So this was the in yellow highlighted cells are all user input, what we input in the user interface. They are yellow, and the rest of the white cells are all calculated. So this was this is what we input for. We had proposed this particular route of Boston Rome for the period of 2020 April to 31st March of 2020. Currency type is USD, and you can see the input of all the parameters. You can this is the number of passengers, local passengers we are expecting, and this was the this figures were estimate forecasting, and this was the market share estimated. These are the local passengers expected to fly, and this was the fares we entered, and local passenger revenues would be this much for each class, and then this is the final figure. And the additional traffic, we put the figures, and the connecting passenger revenue would be for each class would be this, and the final figure would be this. The total number of passengers for each class is this, and the total number of total passengers all over the flight would, over the period would be this. And this was input in the first screen. Then we went for the second screen, and there we input the block hours and kilometers been flown and annual departures, and this is what the RPK, that is a KPI metrics. And then we input the cost per block hours, and this is total per block hours. We get that. And this is the indirect operating cost. We put the percentages for three figures, that is promotion, sales, general, admin, passengers, per applicants, so and so. And this is the loads business class we enter premium class and economy class. The total seats was so much. EASK is generated this much. Seat departures, business load factor is 52%. Premium class load factor and the economic load factor. So these are also the metrics, key metrics. The total passenger revenue was this and the cargo contribution was this. So, and in the end we come and we got this particular direct operating cost. These are the indirect operating cost, passenger service fare, which we input in the above out here. This was and this figures were input by us, and this were the results of this particular input. And then we get operating cost, unit cost, operating profit, and operating margin. So if you look the unit cost is 0.0446, which actually is operating cost divided by ASK. That is ASK, yeah, the ASK, it will be divided by ASK. So we get the unit cost, and the operating margin is 1.70. So that is on every $100 invested, the returns would be $1.7 approximately. So it is up to airline to decide whether to fly this particular route and is it profitable from the airline perspective to fly. So this is the planning report where the route is planned and it is been evaluated. So these are both two applications serving dual purpose of the routes flown and the routes which are planned to be flown. So this is our this is the tool which we have developed, and thanks for watching it.